Hello everyone. Good morning, good afternoon, or good evening, wherever is it that you are. My name is Santanu Dutt, and the topic that I'm going to cover as a part of this session today will be running digital workloads with Amazon Web Services. And my goal really today is that at the end of the next 35 minutes, most of you should be able to answer to these basic questions. One, we'll obviously need to start with the baseline of why you should consider digital and really how other companies are doing digital. We'll then walk you through as to why it is so advantageous to run digital businesses on a public cloud like Amazon Web Services. And most importantly, we'll actually talk about some of the bottlenecks that one can come across on the way to becoming a digital business. And then finally, towards the end, we are also going to have to look at a recorded demo just to see how simple it is to get started with a digital website or a workload on the AWS cloud. Now do note that this is a 100 level session, so it's really basic. So there will be some talk about technology and technical aspects, and we look at a demo as well involving just a few basic AWS services, but we will not be going very deep. Now, as an introduction to what I do, I'm actually the manager of the Solutions Architecture Group for Amazon Web Services for the west of India. That's covering Mumbai, Pune, Gujarat, and beyond. I've been on board the company since 2011, so it's been a fantastic 5 years for me. And in these 5 years, I've had a chance to work with all sorts of customers. Startups, large enterprises, small and medium enterprises, to banks and financial institutes, even educational institutes across India. But that's more than enough about me. Let's talk about you, the audience. This is certainly not a super deep technical topic, as I was talking about a little while earlier, but I'm assuming that you have some knowledge about technology or just a small background in tech, even if it's high level. So I'm assuming that you're either a chief marketing officer or a CIO or a CTO or some sort of a business-facing person within your enterprise. And even if you're a tech person from a sysops and a system admin background, there's something for you in as well. Of course, this being a 101 level presentation, we will certainly not go anywhere near the technical weeds, so don't worry about it. Now, when we talk about digital, people assume the word disruption, that is disruption of industries, which basically means in general, industry segments or industries being overtaken by other businesses in the same thing, by doing the same thing in a more innovative way. And the concept itself isn't new. It might sound new, but it has been there for ages. If you really look at these pictures, if you look at the automobile industry or the transport industry or even the postal industry, the communications, for example, from telephone lines to what we have today, all of these industries were utility services to people. And over time, they just got obsolete because other businesses or other people found a better way to offer some of these utility services in a much better way. And so these changes have really happened over a large period of time. But when we talk about digital disruption specifically, given the rise of the internet, especially in the last, decade or so, it's resulted in a much faster rate of disruption, right? It's actually accelerated. And this is businesses of all size. We have the likes of Airbnb, for example, which when they really started off in 2008, everyone actually discarded them as someone who's going to fail miserably because the hotel industry is really well set. And look at them now today. They're disrupting the entire hotel market across the globe. And they're one of the largest aggregators of apartments or hotel rooms and apartments in the world. Dropbox is doing something similar in the storage industry. And on the same lines, you have YouTube, which is disrupting the ad industry. You have Netflix, which is disrupting the entertainment industry. And of course, the now famous Uber is doing the same thing with transportation. Most of these companies, if you didn't realize, are valued at billions of dollars. And they've taken hardly any time to actually achieve and get to where they are presently. Now, one very large enterprise company that you may have heard of, Amazon.com, is really trying to disrupt multiple industries in its foray, and this is global. One of the things that Amazon does is releases production IT changes, that is software version releases, once every few minutes. That's a lot of changes in a minute. And by way of comparison, we have a large global bank, which I was speaking to recently, that told me that all the big changes that they do are released maybe once every 10 months, unless there is an urgent regulatory need. And in which case they might do it once every 3 months. Now just imagine the level of experimentation and innovation that they can take place if you're constantly testing out ideas with groups of customers. Just imagine you as a person are heading up digital banking and you want to know how customers will respond to a new mobile bill pay feature, for example. Instead of waiting 10 long months to know the customer reaction, you can actually start learning right now, today. And imagine if some of your competitors, for example, can move at this speed. It's actually a scary thought. So you might want to kind of innovate faster. In fact, there's another company which really has one of the largest market caps in the world, over $700 billion today, by the name of Apple. It's really shown us that companies like Apple and Amazon can remain disruptive even after growing big as they are. But how? The question is how? How do you ensure that the rate of innovation remains fast even after growing big as a company? Now, a lot of you might know Amazon from its e-commerce website, and many people today still relate to Amazon from that business and the fact that it has been the largest online book selling business in the world. But as you know, as our CTO Werner Vogels likes to say, Amazon is just a technology company and it just happens to sell books online. And that's actually true because you'd be surprised as to the number of software developers or engineers and other tech people that always work at Amazon, and it's always been a tech company right from day one, and it's probably going to always be a tech company. And that's the DNA with which Amazon Web Services was formed within Amazon as a business. And then, of course, the famous story of it going on from there to offer public services since 2006 by selling IT under a commodity e-business model, what we today know as cloud computing. Now, over time, Amazon Web Services has not only kind of become a digital company, but it has enabled other businesses, hundreds and thousands of customers, move to their digital journey with the cloud. So not only have we seen our own journey as a tech company in the digital space, but we've also been privileged and seen the wonderful journey of other customers going through this similar cycle. All our customers, or most of our customers, are digital business, and really their business models are centered around data and applications and web technologies, and it's just a natural fit to what we do and what they do. Now, here are a list of startup companies that have over the years grown as customers on AWS. As you can see from some of the logos, these are just companies of varying sizes from across the globe. They range from online ad serving companies to media companies to online video and music streaming companies to even businesses like Airbnb, whom I was just talking about a minute earlier. Many of these businesses, interestingly, actually started their business in the initial days, right from day one, hosting their workloads on the AWS platform. Now, here are some enterprise customers. So if you thought that the platform was meant only for startups, you couldn't be more wrong. Enterprises who have over the years started to do a digital strategy on the AWS public cloud platform have been onboarding their workloads on the AWS platform over time. And this includes even organizations like banks, Commonwealth Bank of Australia and Bankinter. There are other companies like Samsung as well, and there are many more. The AWS cloud just happened to be the natural choice for these enterprises to start their digital journey and break free from some of their legacies. And lastly, the public sector world has also been following closely to the enterprises and the startups. So a lot of these government agencies based out of the United States, as well as parts of Asia Pacific, have been just digitizing a lot of workloads and coming up with digital initiatives. And so it's really a lot of these companies of different shapes and sizes and different geographies, which are actually onboarding the public cloud platform with their digital journey. Now let's get into digital itself. We've been talking about digital, but what does digital actually mean? Is it vastly different? And sometimes can it mean different things for different businesses? What is different between a traditional bricks and mortar business and a digital one? What are the rules that you need to keep in mind to implement your own digital strategy, for example? Are there any technical challenges that need to be fixed, or is it more organization or cultural changes, or is it a bit of both? We'll kind of learn about that in a minute. On a fundamental level, a digital business is all about creating value out of data. A typical examples of these could mean web-centric companies like news portals, social networks, search engines, etc. But this also includes companies that successfully bridge the physical world with the internet world, such as companies with, let's say, a connected car strategy, or even small fitness trackers that you all wear on your wrists, even something as simple as that, the Internet of Things as we popularly call. And this is actually extended to heavy industries using sensory data to attach digital services to their equipment. Even banks actually doing this via mobile and online channels and many, many more. And so The fact of the matter is all digital businesses have data assets at the core of their business model, and they use software in some form or the other to create business value out of the data that they gather. And the key point here is software. If your business model depends on creating value out of data, it's software that you create that turns data into value. And so all digital companies, at least most of them, have a focus on software because they are critical enablers to their business models, which is really very different from the traditional world. And so now we are in a position to kind of formulate our first key insight about digital companies. Digital businesses build their business models as code around their data assets. In other words, they actually take their model, codify it around the main asset, which is data, and they actually run that code in order to generate business value. Now let's keep collecting these insights. We'll kind of come back to this insight again towards the end, but there are more insights to follow after this. Now you might ask, what about hardware? I spoke about software and I kind of emphasized on software, but if I've just been talking about software, you might wonder, doesn't software actually need to run on hardware itself? Don't you need underlying servers to run all these applications? Shouldn't digital businesses focus on hardware, such as private clouds or virtualized server farms in order to run software and store the data? Well, the reality is in the old world, that was to some extent true. The old IT model is indeed centered around an organization. And the main task of that organization is really operating a state-of-the-art virtualized data center operation, which many will today call as private cloud. Software can then be deployed as applications on top of virtualized hardware. And this virtualization part really ensures a better flexibility and utilization of the underlying resources. This has really been a key improvement from an even older IT model years ago when software and hardware were tied into each other 1:1, or in some cases even 1:2 because you needed two kind of components to maintain high availability. Now the key point here is with both models, operating hardware is a very, very cost-intensive approach. It's slow, it's inflexible, and it's an inefficient approach. Even at the software level, not considering the effort to operate data centers alone, running software requires a lot of effort in such an environment. You need building, testing, releasing, patching, monitoring, improving your software, and much, much more. And really, it doesn't really matter if the application is already bought or in the open source form. It actually comes down to the same thing. But in the new world, this is the public cloud-centric world, all of these operational issues go away because customers can literally now deploy their software, third-party or open source, on an unlimited scale of resources with no financial risk because cloud is a pay-per-use model, so there are no financial liabilities. And it's completely on a dynamic architecture that is 100% automated with minimal manual effort to deploy things in a matter of minutes. And it's worldwide infrastructure, especially with AWS, given all the regions we have worldwide. So you really don't need a data center. So the main takeaway is that there are no physical constraints. The cloud computing removes all physical limitations of traditional IT. IT resources can now be provisioned in minutes and not days and weeks. And it has a rich choice of virtual machine types, storage flavors, networking options. You can really take advantage of the higher level services, remove the burden of standard software, and replace it with software as a service with databases, Hadoop clusters, search engines, or even machine learning applications. Of course, cloud is not an all or nothing approach, so you can always mix your existing data center with the cloud in a hybrid model by creating a VPN or even a physical connection with a lease line if you wanted to integrate your on-premise data center with applications which are on the cloud. And in fact, most enterprise customers, end up doing exactly that. Now, the other key point is that the cloud or cloud computing is available to everyone, which is anyone who has a credit card or an invoicing bank account can actually have access to the cloud. You just don't need anything. There are no minimum investments necessary because it is a pay-per-use model. That's the very point. And so cloud computing has therefore done an effect on IT on what we call as leveling the playing field. That is, every now a big organization or a small startup has the same access to the huge and powerful IT capabilities as everyone else. It doesn't really matter. You could be a student to a startup, to small and mid-sized company, to large multinational enterprises. And this is important to keep in mind when looking at digital competition. These set of factors alone has resulted in Amazon Web Services now having 1 million plus active customers. And these are non-Amazon customers, non-Amazon.com customers. So these are customers like everyone else out there, small startups, big enterprises. And these are all active customers. There are no dead signups here which are counted. So you might ask that if access to IT infrastructure, data centers, or other physical IT resources are no longer a differentiating factor for a digital company, because that's available to you in an easy way anyway, we are now closer to formulating the next business insight here, right? The physical data center is no longer a differentiator, but the differentiator is really differentiating yourself purely through ideas, data, and customer relationships. As a consequence, competition in digital space is purely virtual, focused on getting new ideas to the market faster, doing a great job of collecting and analyzing and predicting data. These are your big data analytics and BI tools. And finally, closing the feedback loop with your customers quicker to react to their needs much faster. And by using this strategy alone, Amazon Web Services over the years has really focused on creating new services and features on a platform, and based on usage data and customer feedback, have iterated faster like never before. Last year alone, in 2015, in 52 weeks, we had 722 major services and feature releases. Most large companies actually slow down after they get bigger. With AWS, it's been the other way around, which is it's become faster as it's grown bigger. And today, since inception of 2006, when it started selling IT services over the web, we really have about 2,200 feature releases in public domain, and our service portfolio has expanded 60 major services. And this is just more than virtualized servers, storage, or networking. Lots and lots of high-level services with respect to big data, mobile, messaging, NoSQL, databases, and much, much more. Which now leads us to form our rule number 2 for digital businesses, the second insight being that digital companies bring new ideas quickly to market, analyze the data really quickly, which is in real time almost, and really they put the customers at the center of what they do to close the feedback loop faster with them. But if you have these insights, and let's say people kind of get these insights, what is the bottleneck for new companies to adapt and get into digital? If physical IT limits are no longer an issue, and assuming that you as a customer have access to all this unlimited supply of hardware in the cloud, what's the next bottleneck that can slow you down in your transformation into a digital company? And how do you actually get around those? Here's a thought for you. Would you want your company to be one on the right, which is the picture, or would you want your company to be on the left? Well, the right one is the Tyrannosaurus Rex, an apex predator during its time, which was an actually dominated predator during its time. But it became extinct after a while for reasons that some of us know. But in fact, you might want the company or your company to be the one on the left, because L greater than C means your rate of learning is greater than the rate of change in the industry. So the rate of change that is happening in the industry and the ecosystem around you, your rate of learning might want to be more than that for you to survive. Enterprises don't really have the option of moving slowly anymore. At least you can't move slow if you want to remain competitive in the longer term. Customer needs, competitors, and the market is just moving way too fast. And if you really slow down, you'll end up falling into a death spiral that ultimately leads to extinction. So your rate of learning has to be faster than the rate of change in the environment. And so for that, you have to be obviously agile, innovative, and this environment needs to be competitive. And most importantly, you have to all do this in a cost-effective way. Now, if you go back several years ago, Amazon was in a slightly similar situation as well. The website was an architectural monolith. It had multiple tiers for sure, but it was really consisting of tightly coupled components. And this monolithic first architecture is not uncommon with many fast-growing startups, because you do make early trade-offs to kind of keep you in good stead for short term, but but then over long term, you get into long-standing issues. And with Amazon, the same thing that happened, and as we scaled the website, the team and we started to get bogged down back then. But it then went through a transformational journey to kind of get around that. And it's still easy to digitize in startups and in companies like Amazon as it stands today, because monolithic applications and enterprises really act like a big fat anchor that can actually tie you down, which leads to what we call as the waterfall mode or waterfall model. Change is a big deal in enterprises. You don't want to do it often, and when you do it, you'll at least spend a few weeks doing an impact analysis. You absolutely want to make sure it doesn't fail, or you will spend the next few weeks or months just filling out post-incident reports. And before even starting on the paperwork, you'll need to ensure that you roll back to the system to its last known good configuration. And this results in a much, much larger effort. It's obviously higher risk as well, and so it's inefficient to do this. This actually ties back to the example that I gave towards the beginning of my presentation of a bank wanting to apply a change once every 10 months. It's not going to fly for too long on the long term. So, which is how you actually come to the diagram on the right, which is the more dynamic and agile method of applying changes, which are much smaller but more frequent. And what happens with that is with smaller incremental changes, the risk of failure of your change is much, much lower. This directly leads to rapid learning at a rate much higher than the rate of change. Which now finally brings us to insight number 3 of digital businesses. That is, digital businesses actually adopt a microservices architecture style and a DevOps culture. And so if you actually look at it, there's a small change in rule number 1 where I've added the word core. So it's important to your business to not, to build what is core to your business, but not waste time reinventing the wheel for things like search engines, big data, infrastructure, message queues, or other middleware, because that's all available on the cloud for you to leverage. Unless, of course, that specific tool happens to be the core of your business. So what are the best practices to kind of get there? How do I get started? What are the workloads I can start with on the public cloud, for example? A lot of customers have these questions. And unlike what you're thinking, you may be thinking on, you don't have to throw everything away. Because guess what? While you get more efficiency from cloud native applications, even a simple lift and shift for a certain semi-legacy application can give you a quick improvement in cost. So you might want to start with the lift and shift of certain apps as required in phase 1 of your cloud migration. And then this could be about 1 to 3 months from the start of migration. Now, once applications are away from the slow-moving enterprise data center environment, you can then start to optimize and innovate. Cost reduces even more when you start to make use of certain high-level services like storage services with S3 or CloudFront, which is our CDN service. And with these services, you can actually offload some of your heavy-duty, logs, images, videos, and they can actually start serving this. This phase 2 can be anywhere between 3 to 9 months time maybe, or a little more. And lastly, you can then have your development teams become comfortable with the new normal of cloud, where you can begin to write cloud native applications. This can be done approximately 3 to 6 to 12, or sometimes even 18 to 24 months time. Just imagine transforming into this and running the entire enterprise suite of applications, actually not having managed an operating system, never mind a physical server as well. This should ideally be your end goal and your end state after moving to the cloud. So ultimately, this is not about looking back at your earlier stages of your org and continuing to do just the same things or make minor improvements above that. It's really about moving ahead and staying ahead of others with an innovation curve. It really is about transformation of IT, and using IT itself to transform into a fully lean enterprise. Now, customers in general who are novice to the cloud and they're new to get started off, try and look at various workloads, which are low-hanging fruits to move to the cloud. And the ones that they typically look at are dev test or DR and backup, or even backend applications, the non-production applications which are in-house. And they are less critical and typically tend to be the first candidates to go to the cloud, as that gives them an easier way to test the waters because they're new to the cloud. But digital workloads, especially within enterprises, are usually greenfield apps. And when it's a new initiative or a workload being built, it can usually be easier for the cloud to migrate. Let's talk about a quick customer case study. There are obviously several of them, but in the interest of time, I'm going to cover just one. I'm sure that everyone's heard of the famous company D-Link, based in Taiwan. Now, what D-Link was doing was they actually planned to launch a cloud-based service portal called My D-Link Cloud Services to enable customers to view, control, and share network-connected devices such as IP cameras and routers. And they also wanted to manage the storage of the data coming in from there. Now, to achieve the best speed and lowest latency possible, D-Link actually wanted to distribute this entire infrastructure for the portal globally and deploy the service from locations like in the US, Asia, or even Europe. And the company wanted an efficient solution to manage peaks in customer usage without actually investing in IT resources for paying for idle capacity. And so AWS, really the platform, worked perfectly for them, given the global presence that we have with the multiple regions. And they could use the multiple regions per their end user customer base. Pay-per-use model for kind of managing the peaks and the non-peaks. And really at the end, it took them just 6 weeks end to end from launching that idea to actually launching the portal itself and migrating that to the cloud. And they estimated that they actually saved 50% in IT costs, and compared to what it would have costed them or would have costed them in running this in a traditional enterprise data center. And so this is a classic case of an enterprise succeeding in deploying a digital workload globally within no time at all. All right, so enough said. How about showcasing a quick demo for you people? Because what we'll show you in a recorded screencast of a demo which I've already recorded is we'll take pages from a static website, including HTML, images, and all that, and really put all of them together to make a perfectly working website on AWS. But here's the thing, we will actually do it without running compute or server instances, because as a general practice, the more compute you run, the more expensive it does become on the cloud or inside a data center. And to run and manage them operationally becomes a pain. And so what we'll do is we'll actually use our static storage store, which is S3 or simple storage service, for hosting this entire static website. And to extend this a little further, we'll have CloudFront, which is our CDN service, front-ending this, plus we will serve this via HTTPS. By the way, to generate an SSL certificate is super simple on AWS because it just takes a few clicks, and believe it or not, it comes completely free from Amazon. So no waiting for months and getting into the complexities of getting a certificate to run your secure website. So let's go on and check the demo for now. So now what I do is you actually see an AWS console. I'm actually creating an S3 bucket, and I'm going to name the bucket with a name so it's easier to identify. A bucket, by the way, is just a normal container in which it's a logical container to which you upload files. And what I've done is I've created this bucket in the AWS Singapore region, and on my laptop, I already have files downloaded from a static website. So what I'm going to do is to make this bucket serve as a static website, I'm going to upload all my files from a laptop to this bucket. Once that is done, the S3 bucket is reasonably ready. And what I'm going to do as a next step is go to my CloudFront distribution or our CDN service, as I just mentioned, and fill up a small form, which is a configuration form. And it's really simpler than you think, because all you need to do is on this page, fill in some of the domain names and some of the specifics. You can start with starting your origin domain name. You can probably take most of the defaults after that. And then if it's just a test that you're running, and you can probably put in a CNAME in there as well. And that should be it in terms of the CloudFront, POP locations, and they will start caching content once this is live. After I've done with actually writing the CNAME, it's time to actually start generating an SSL certificate. I actually already have one certificate in place, but I'll actually go ahead and generate another new one for this demo. And so I kind of put in my domain name and all those details. And once I'm done with it, this will actually go to the next stage, which is actually validation and approving of the certificate, just to ensure that everything is fine. As you will see, I've already got an email with a link for me to actually confirm on that. And it takes me to the next page, which will ask me to actually approve this certificate. And once I do that and it checks that it's kind of appropriate with all the domain name in place, we're going to actually start seeing the certificate in the CloudFront page, which means the CloudFront distribution itself will now be HTTPS enabled. So you have a completely secure website running on the cloud, backend with X3 and the CloudFront in front. But one last step, we obviously need a DNS service for end users of your website to actually type a user-friendly name which kind of relates to your domain. And so I've kind of taken a domain, and what I'll do is I will use Route 53, which is Amazon's DNS service in a while, to actually host this domain zone file and make it really easy to point to the CloudFront distribution, which is exactly what I'm doing right now. So what I'll do is I'll take the domain name, I'll take the endpoint in the drop-down window of the CloudFront distribution, and I actually end up pointing to it so that when your end users start pointing this domain name and start typing it in the browser, voila, it'll actually take you to the website. And that should happen in the next few seconds or so. We'll just give it a few seconds for the pointer to happen and apply the changes. And once that's done, I will actually pull up my browser from my laptop to actually go and see whether the website is working. It should happen any second now, and we're up with the browser. And so I'm typing the domain name. As you can see, it'll take me and change the page to a summit page, AWS summit page from one of our previous summits in a different city. And the website is up and running. Now, this is a fully ramped up, fully operational website running on storage service without any compute or any service, front-ended by CloudFront, and it's end-to-end HTTPS. So a great example of how you can get up and running with something as simple as this. Now that we are done with the demo, and I'm almost at the end of my presentation, let's kind of do a quick wrap-up of this session. So what did we actually learn? We actually learned the three main insights into digital businesses, which was digital businesses build their core business models around their data assets. Digital businesses bring new ideas, analyze data in real time, and really put customers at the center of what they do. And finally, the most important one, they actually adopt an innovation culture. They don't get stuck to legacy. And you must realize that this entire process is just much more than technology, because you have all these building blocks, the colored blocks that you see on your screen, which go into making a truly digital company. Try and avoid nostalgic strategies, because if you do, you'll actually then get stuck back again with your legacy. And lastly, if I were to have you take some key takeaways from this, here are some of them. The irony of this talk is the key thing about building a digital business a lot of it happens to be non-technical. Think about culture in your organization, or how you can change it into an organization that finds, develops, and rewards builders that form a culture, which is much more dynamic and empowered and oriented towards ownership. And that really allows you to kind of have a team which kind of experiments often, continuously, and iterates often. Talk to your architects, after hiring them, about adopting a microservices culture inside your organization, and just bring your developers much more closer to your ops people. That really enables a true DevOps culture. And the path after this transformation becomes much easier for the long term, for the foreseeable future. Now, I'm almost done with my presentation, but I just have a couple of parting thoughts for you. To gain more confidence and hands-on experience with the AWS, you might want to watch our instructional videos, which are instructor-led in a video, and explore our self-paced labs at home. You could also attend, if you wish to, instructor-led physical classes by qualified AWS trainers and instructors, and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. You could then, in fact, go ahead and validate your technical expertise by taking some practice exams and getting accreditations with certifications. And we do have a lot of certifications of various levels of difficulty and under various domains. That's it from me. Thank you very much for attending this session. We hope you found it useful. Do ensure to provide us with your feedback and let us know how we can improve the event experience for you in the future. That's it from me for now. Cheers.